Hello, global ecology students. This is Michelle Miller, and I am going to be writing the answers for the nutrient pollution simutext questions that you needed to answer. So you had a whole workbook that you would have filled in, and that was awesome. But rather than having you email that whole workbook to me, I wanted you to distill, or I kind of put into just a few ideas, the significant questions that were posed in this lab. And because I have twice as many of you as under a normal circumstance during the quarter, I thought it would be good for me to record kind of an answer key for you, as it will, and then you might have a grade, you will have a grade in your lab, in your Canvas, and that grade will be based upon these criteria that I'm going to outline today. Okay, so if you look at this question, it has to do with the relationship between algae and dissolved oxygen. Now, algae is actually a producer, so it is photosynthetic, and it produces oxygen. However, if there's an overabundance of algae, so you imagine like a river in your town, like Umatilla River. In the summertime, sometimes it turns green and slimy, and that is what is referred to an algae bloom. And the algae overshoot their carrying capacity, and then they die. And then it is the subsequent decomposition by bacteria that causes the dissolved oxygen levels to decrease. So ultimately, the algae overshoot and then die, and then the bacteria use cellular respiration, so they use up the oxygen, and that's when we get this anoxic environment. So anytime you have an A in front of a word like this means without. So this is without oxygen. And so this can be very bad for aquatic organisms that need to be able to get oxygen from their environment. So that is the answer to this question. Okay, so let's go to the next question, the next page. Why could having consumers as well as producers present in the lake change the amount of dissolved oxygen present? One way is that the consumers use oxygen. So we're talking about like crayfish. They are oxygen consumers. However, they might also eat some of the algae, right? Or there might be other consumers that eat the algae. And so this idea is that there's this dynamic relationship. There's this system. So you have inputs and outputs, and you have flows and storages. So this is a systems perspective. And when I'm looking at this, I'm thinking, maybe if I had consumers present, they might keep the amount of algae in the water from becoming too great. And so that might actually cause the dissolved oxygen levels to be higher. So even though they're using oxygen, their role in maintaining healthy populations of algae might actually cause an increase in dissolved oxygen. So that is what I was looking for in this question. Okay, so the next question. Do the experiments you conducted in the lab show evidence of biomagnification in the lake? So this doesn't have to do with nutrient pollution, because nutrients are water soluble. They come into our bodies, and they leave. But there are some toxins that start to accumulate in the body that are water insoluble, so I can't get rid of them, and they might be stored in my fat. And the example of the toxin in this was mercury. So when I was a kid, we played with mercury, right? You would break your thermometer and you'd have like the mercury ball, and then pretty soon you'd play with it enough, it might have probably absorbed through our skin, that it was just like dissipated in the environment. But this mercury is something that doesn't ever go away. And once it gets into your body, then it goes to whatever eats you. And so the producers have relatively low amounts of mercury, but as you move up the food chain, they become higher and higher. So this is why, for example, when you go to a doctor's office and you're pregnant, you will see signs that say, please avoid eating tuna while you're pregnant. And that's because tuna are big fish and they concentrate mercury in them. And if you eat a lot of tuna, like if you ate it every day or every week even, they have a recommended amount that you're supposed to eat when you're like not pregnant. But that will start to accumulate in your body and it will become a problem. So actually eating lower on the food chain is better in terms of the amount of toxins that you ingest. Interestingly, we can ingest some of these toxins, these fat-soluble toxins, from milk. And so cows, for example, they can produce milk that we then drink, but that milk could be contaminated with some of these persistent, they're actually persistent organic pollutants that stay in their body. Okay, so we did find evidence of biomagnification. Okay, probably the trickiest question was this difference between cyanobacteria and green algae. So if you look at your SIMU text, you probably figured out that you could find information about these critters by looking at the toggling here. So if I look at green algae, then up pops a box and I read about green algae. And I say, in most times, it's part of a healthy ecosystem, but those algae blooms are a problem. And then I can go to the cyanobacteria. And the important thing about these cyanobacteria is that they are actually nitrogen fixers, which means that they do not need to have nitrogen in the water from sewage in order to do well. That means when you're a nitrogen fixer, that means that you can actually take nitrogen out of the water, out of the air, out of the atmosphere, and incorporate it. So you are not limited. This is not, nitrogen is not a limiting resource. So right there, I would say, I think if there was phosphorus, but there was very little nitrogen, I would think that the cyanobacteria would outcompete the regular green algae. So I could change this and alter, these are my independent variables, right? And I can alter those. These, the population size, are my dependent variables. So let's say if they're the same, I could run it. And I started out with a lot more cyanobacteria in this particular example, but I'm running it and I'm seeing that there's, yes, there's more, still more cyanobacteria, but I started out with a lot of cyanobacteria. Green algae are still doing pretty well. And I probably should have sped it up. Speed, I don't know if I can change it. But anyway, you'll notice that there's a little bit of fluctuation. Oh my goodness, the green algae are almost catching up, right? So there's not this shooting abundance of cyanobacteria. Okay, so let's stop that and I'm gonna reset my numbers. And then I am going to turn nitrogen down to 0 and I'll just leave phosphorus the same. And then I will hit go and I will run it. And look at what happens. Because this algae needs nitrogen from its environment, the cyanobacteria are going to outcompete them and they're going to become very abundant. This would be even greater if I added a little bit more phosphorus. There would be a bigger shooting because phosphorus is a limiting nutrient for the cyanobacteria. So let's stop that and let's do that. So a lot of you said, well, if you have high phosphorus, then you're going to have lots of cyanobacteria, but you have to have high phosphorus and low nitrogen in order for the cyanobacteria to really, oh, look at that, it's going crazy. Okay, now why is that such a bad thing? You probably have heard of dogs dying when they go to a lake and they drink the water. Cyanobacteria, these blue-green algae, these blooms sometimes produce a neurotoxin. And if you drink that water, it can cause the animals to die. And sometimes you get even fish dying, you know, so it's a neurotoxin that once it's ingested, it actually just stops the nervous system. And this is a very bad thing to have happen because it kills the animals in the body of water. And anybody who drinks it is also going to be poisoned. And so that's why it is such a bad thing. Okay. So let's look at the very last thing you needed to do. So write a letter to the editor of a paper it's worth 15 points. So I must need more than one sentence, right? And so what I wanted you to do here is to outline the science and explain it to a person in an unscientific maybe manner, but I mean, a kind of a serious manner. So what I would do, I would say is the sewage being dumped into our local body of water is bad because this is a form of nutrient pollution, and we can expect that when this happens, we can have an algae bloom, which causes eutrophication. It might seem like it's a good thing to put nutrients into the water, but it's not, because it's going to cause a dramatic decrease in dissolved oxygen, and it's going to make the organisms that depend upon that oxygen die. And then you might add in our sewage not only includes these pollutants, but it also includes mercury. And mercury is a toxin that once it gets into the lower levels of the food chain will start to accumulate. And so we would predict that having this raw sewage go into the body of water could be bad from that perspective as well. So that's what I was looking for, not just, dear editor, I would recommend that we don't dump the sewage in the lake, period. Sincerely, your name. Okay, so I hope that this was at least answered some of your questions. And if it didn't answer why you got a particular score on your assignment, please let me know if you need any other or further explanation for this particular lab report or lab information. Thank you.